The ocean, a vast and unexplored frontier, covers more than 2/3 of our planet, dominating the Earth's surface with its immense presence. It's a realm of constant motion, a dynamic interplay of currents and tides, shaping coastlines and influencing global weather patterns. Yet, despite its significance, its deepest realms remain shrouded in mystery, concealing secrets that have captivated scientists and explorers for generations. These hidden depths hold the key to understanding our planet's past, present, and future. Beneath the waves, beyond the reach of sunlight, lies a world where sunlight never reaches, a realm of perpetual darkness. Here, the familiar rules of the surface world no longer apply. It's a place of crushing pressure, where the weight of the water column bears down with immense force, and freezing temperatures, where the cold seeps into every corner. It is a world of eternal night, where the sun's life-giving rays are absent, replaced by an all-encompassing darkness. This is the abyss, a realm that challenges our very understanding of life. For centuries, we assumed nothing could survive in this abyss, imagining it as a barren wasteland devoid of life. The extreme conditions seemed insurmountable, a barrier to any form of complex existence. We were believing it too hostile for complex life, a place where the fundamental requirements for survival were simply absent. The deep ocean was considered an uninhabitable zone, a stark contrast to the vibrant ecosystems of the sunlit surface. But the deep ocean defies our expectations, constantly surprising us with its hidden wonders and unexpected inhabitants. It challenges our preconceived notions about the limits of life and the adaptability of organisms. It is challenging the idea that all life depends on the sun, revealing a world where organisms have evolved unique strategies to thrive in the absence of light. These creatures have unlocked the secrets of chemosynthesis, harnessing energy from chemical compounds instead of sunlight. Here, life has found a way, adapting and evolving in remarkable ways to overcome the challenges of this extreme environment. It's a testament to the resilience and ingenuity of nature. Powered not by sunlight but by energy from the Earth itself, life flourishes around hydrothermal vents, underwater volcanoes that spew out chemicals that form the base of the food chain. These vents are oases of life in the otherwise barren landscape. Exploring these depths is one of humanity's greatest adventures, pushing the boundaries of technology and human endurance. It's a quest to understand the unknown, to unravel the mysteries of our planet. It is demanding courage and ingenuity, requiring specialized equipment and highly trained personnel to venture into this hostile environment. Each dive is a step into the unknown, a journey into the heart of the abyss. Each dive reveals a vibrant world, teeming with bizarre and fascinating creatures that have adapted to the darkness. The beams of submersible lights cut through the blackness, illuminating a hidden realm of life, forcing us to rethink what it means for a place to be alive, challenging our understanding of ecosystems and the interconnectedness of life on Earth. The deep ocean is not a desolate wasteland, but a thriving ecosystem with its own unique food webs and ecological interactions. The ocean's darkest corners may hold our planet's greatest secrets, waiting to be discovered and understood. These hidden depths may contain clues to the origins of life, the evolution of species, and the future of our planet. Our journey begins in the silent, sunless depths, a realm of perpetual darkness and mystery. We descend into the abyss, leaving behind the familiar world of sunlight and entering a realm of the unknown, where life rewrites the rules, defying our expectations and challenging our understanding of the natural world. Here, in the deep ocean, life has found a way to not only survive, but thrive, illuminating the darkness with its own unique forms of bioluminescence. The Northwest Pacific Trenches are among the most extreme places on Earth, immense chasms plunging nearly 6 miles down. If Mount Everest were dropped into one, its peak would still be a mile beneath the surface. The pressure here is over 1,000 times greater than at sea level, and the cold is relentless. For years, scientists believed these depths were biological deserts, too harsh for anything but a few hardy microbes. Previous dives revealed only isolated creatures, drifting through a vast emptiness. The consensus was clear: complex ecosystems couldn't exist here. But recent discoveries have shattered that belief. Instead of emptiness, scientists found a bustling metropolis of life. The deep isn't just surviving, it's thriving, rewriting our understanding of where life can flourish. The boundaries of biology have just been pushed to new extremes. As the submersible touched down on the crushing depths of the seafloor, A hush fell over the team inside. The only sounds were the hum of the vessel's systems and the quiet anticipation of what lay ahead. This was a journey into the unknown, a descent into a realm rarely seen by human eyes. Scientists expected barren mud, a desolate landscape sculpted by immense pressure and perpetual darkness, and perhaps the occasional lonely creature adapted to this extreme environment. The textbooks painted a picture of scarcity, a biological desert where life eked out a precarious existence. Instead, they found a garden, dense communities of tube worms and clams carpeting the abyss, a vibrant tapestry of life where they expected to find almost nothing. It was an explosion of biodiversity, a hidden oasis thriving in the most unlikely of places. Towering tube worms, some reaching incredible heights with brilliant red plumes, unfurled like exotic flowers in the underwater gloom. These were not the stunted, struggling organisms they had anticipated. They swayed in thick clusters, gently dancing in the faint currents, a mesmerizing ballet of life in the deep. The sheer density of these creatures was astounding, a testament to the unexpected bounty of this hidden world. And surrounding them were beds of tightly packed clams, their white shells gleaming in the submersible's lights, forming vast colonies that stretched as far as the eye could see. This was no sparse collection, no mere scattering of survivors, but a thriving ecosystem, a bustling metropolis of life in the deep sea. It was a revelation that challenged everything they thought they knew. It was more reminiscent of a coral reef, teeming with life and vibrant energy than a lifeless plain, a stark contrast to the barren landscape they had envisioned. The sheer abundance stunned the team, their faces illuminated by a mixture of awe and disbelief as they witnessed this extraordinary spectacle. It was home to thousands of animals, living in total darkness, completely independent of the sun's energy. This discovery rewrote the rules of biology. These creatures weren't surviving on scraps from above, on the meager rain of organic matter known as marine snow. Instead, they'd tapped into a new energy source, a hidden power that fueled this remarkable oasis. The discovery raised urgent questions that would occupy scientists for years to come, driving new research and exploration. How did so much life exist here, in this seemingly inhospitable environment? What fueled this hidden world, this vibrant ecosystem thriving in the absence of sunlight? The answer would challenge everything we thought we knew about life's requirements, forcing a re-evaluation of the fundamental principles of biology. In the deep, far from the reach of the sun's rays, life had found a way to bypass the sun entirely, forging a new path and rewriting the rules of survival. The abyss was alive with possibility, a testament to the resilience and ingenuity of life, and a reminder that the greatest discoveries often lie in the most unexpected places. Far beneath the ocean's surface, where sunlight fails to penetrate, lies a hidden world teeming with life. The secret to this deep-sea garden is chemosynthesis. It's a process that defies conventional understanding of how ecosystems thrive. Chemosynthesis is a remarkable biological process where life draws energy from chemicals, not sunlight. Unlike the plants and algae that power most ecosystems through photosynthesis, these organisms harness the energy stored in inorganic compounds. At hydrothermal vents, seawater seeps into the Earth's crust, infiltrating the very foundations of our planet. As the seawater descends, it becomes superheated by the Earth's molten core and erupts back into the ocean with tremendous force. This eruption carries with it a cocktail of dissolved minerals and gases, most notably hydrogen sulfide. To most life forms, these chemicals are incredibly toxic, posing a significant threat to their survival. But specialized bacteria, extremophiles adapted to these harsh conditions, thrive here, forming the foundation of this unique ecosystem. These bacteria are the key to chemosynthesis. They convert hydrogen sulfide into energy through a complex metabolic process. This energy fuels their growth and reproduction, forming the base of the food chain for a diverse community of organisms. Tube worms and clams, iconic inhabitants of hydrothermal vent ecosystems, rely heavily on these bacteria for their survival. They have evolved a remarkable partnership, housing the bacteria inside their bodies in a symbiotic relationship that benefits both organisms. Tube worms, for instance, have no mouth or gut. They are entirely dependent on their internal bacteria for sustenance. The bacteria within their tissues do all the work, turning chemicals into the nutrients the tube worms need to survive and thrive in this extreme environment. Clams, too, have developed a similar strategy, hosting chemosynthetic bacteria in their gills. This allows them to create a self-sustaining food factory within their own bodies, independent of sunlight or organic matter from the surface. This entire ecosystem is powered by the Earth's internal heat, a testament to the planet's capacity to support life in unexpected ways. It's a world where life flourishes in perpetual darkness, far removed from the sun's rays that sustain the majority of life on Earth. Every meal consumed in this unique ecosystem can be traced back to the energy derived from chemical reactions, a stark contrast to the photosynthetic processes that underpin most food webs. Chemosynthesis, not photosynthesis, is the engine that drives this extraordinary realm. The discovery of chemosynthesis revolutionized our understanding of life's possibilities, proving that life can build entire communities and thrive in the absence of sunlight. It demonstrated that sunlight is not a prerequisite for life's existence. It opened our eyes to new possibilities for life, expanding our understanding of the conditions under which organisms can survive and flourish. This discovery has profound implications for the search for life on Earth and beyond, suggesting that life may exist in other dark, chemically rich environments, both on our planet and in the vast expanse of space. The deep sea's miracle, the chemosynthetic ecosystem, is a testament to life's incredible adaptability and its capacity to thrive in the most unexpected and challenging environments. What's remarkable isn't just that life exists here, but how abundant and diverse it is. Tube worms form dense forests, while clam beds stretch across the seafloor, creating a living mosaic. The biomass rivals that of shallow reefs, overturning the idea that life thins with depth. This abundance supports a complex food web. Predatory crabs, shrimp, and fish all thrive here. These deep-sea cities are as organized and dynamic as any ecosystem on land. The discovery suggests the deep ocean is a patchwork of deserts and oases, each powered by geologic energy. We've explored less than 1% of the deep sea. If such vibrant communities exist here, what else might be waiting in the darkness? The deep ocean's true richness is only beginning to be revealed. Descending in a submersible is a journey into the unknown hours of darkness, isolation, and anticipation. Scientists peer through thick portholes watching as the abyssal plain comes into view. The moment the lights reveal teeming tube worm forests and clam beds is pure awe. Years of preparation culminate in a single, breathtaking discovery. The silence in the cabin is filled with wonder and disbelief. One scientist compared it to landing on another planet and finding a forest. The beauty of the scene, the white clams, the red plumes, transcends data and charts. These moments remind us that science is driven by curiosity and emotion, not just facts. The journey to the ocean's depths is a pilgrimage to the edge of the known world. Even today, there are new worlds to discover right here on Earth. Beyond tube worms and clams, the deep-sea city teems with strange and wonderful creatures. Ghostly white crabs scavenge among the shells, while bizarre, newly discovered fish slither and rest on the seafloor. Swarms of amphipods, delicate snails, and sea cucumbers fill every niche. Each species is a unique adaptation to life in darkness and pressure. Every sample of mud may contain dozens of unknown microbes and invertebrates. Scientists are just beginning to catalog this hidden biodiversity. Each new species is a story of survival in the planet's harshest environment. The deep sea is a frontier of discovery, with countless secrets still to uncover. This discovery forces us to redraw the map of life on Earth. We once believed rich ecosystems were limited to sunlit waters. The deep was thought to be a desert. Now we know life can be just as vibrant in the abyss, powered by the Earth itself. The thriving communities at 6 miles deep prove that high pressure isn't an insurmountable barrier. The deep ocean, the planet's largest habitat, may be far richer than we imagined. If oases like this exist, we've underestimated Earth's total biodiversity. The map of life is three-dimensional, running deep into the planet's core. This is a humbling reminder. Our understanding of Earth is still incomplete. The greatest discoveries may lie not in space, but beneath our own oceans. The deep sea challenges us to keep exploring and questioning what's possible. Discovering thriving life in the abyss expands our vision beyond Earth. We once searched for life only on sunlit planets, but chemosynthesis shows life needs only energy, not sunlight. Icy moons like Europa and Enceladus may have dark oceans and hydrothermal vents, just like our own deep sea. If life thrives here, it could exist elsewhere in the universe in places we never thought possible. The creatures of our abyss are, in a sense, Earth's own aliens. Our journey to the ocean's depths is also a journey into cosmic possibility. The persistence of life in darkness inspires hope and curiosity on this world and others. The ocean's mysteries may hold the key